Alright, so a rescue boat spots a lost hiker on the edge of a rock shelf. How far is the boat from the hiker? So we're finding the distance from boat to hiker. We know this angle. Now, what I was saying before is we did a few of these with like right triangles. So this cliff is not going straight down. It's going at an angle. So it's not a right triangle, which is why we're going to use the law of sines. So this angle is across from this side. So that would be part of your proportion. You would do sine of 35 degrees over 66 equals, and since we're trying to find x, we want to use the angle across from x, so 68. So equals sine of 68 over x. You always want to make sure that the number that goes next to sine is the angle number, and these proportions could be the other way, so you could do like 66 over this equals x over this. You could do it that way as well. It's the same answer, but you always want to make sure that you're putting the right corresponding pieces together. So sine of angle goes over the side across from it. Now we'll solve by cross multiplying. So we're gonna multiply these two together and get x times sine of 35. Then we'll multiply these two together and get 66 times sine of 68. So we cross multiplied, so x is being multiplied by sine 35, which means we can solve for x by doing the opposite of multiplication, which is what? Division. So we're gonna divide by sine 35. Whoops, weird. Why did I do that? Okay, so we get x equals 66 times sine of 68 all over sine of 35. So when you're plugging it in the calculator, I recommend using that fraction feature that I showed you. You hit Control Divide, and it makes like a little fraction for you. And then you can put this on the top and then this on the bottom. So
I got
0.06.
Yeah.
0.7.
0.7, yeah.
Okay.
Okay.
And is that a rational answer?
Indeed. Not.
I mean, what would you expect given the circumstances?
Really big 102.
If this number is 135 and this number is 66, and you're looking at the picture and everything seems pretty large, right? What would not be a rational answer?
I feel like
15.
100.
Like 15, yeah, like
like
something really
2.
small, or something negative maybe. Those would not be rational answers. Okay, or maybe something way too big, like 2,000. Probably not. It doesn't say where to round to, so I just rounded to the nearest 10. Question?
For the second part,
Is
yeah,
there- Yeah.
you just multiply by the common, or the not common, the denominator
Yeah.
on each side.
This part I got from cross multiplying, so I did x times this, that's this,
Okay.
and 66 times sine 68, that's this part.
Yeah.
And then to solve for x, I just divided by what was next to x, so that these would cancel, and I'd get x by itself.
Okay.
So whatever's next to x, you divide by.
It would just be like doing like one of those.
Be the same as if it was like
12 and you just
35x equals 68, you know how you divide by 35?
Yeah.
That's basically what I did. It's just that it's the sine of 35 and not just 35.
Okay.
Like x was being multiplied by sine 35, so I divided by it to get rid of it.
Okay. So you do that to whichever one is like most likely itself, like top and bottom.
Yeah. Well, you don't have to necessarily show like this step if you want to just skip to that step, but I just.
Okay.
Alright, so let's take a look at the next example. I'm gonna draw a triangle. So they didn't have the triangle here, so we want to practice our triangle drawing skills.
Of these
So the first thing I'm gonna do is draw a triangle. It doesn't have to be to scale or anything. I'm gonna label it A, B, C. It says angle A is 48. Angle B is 93. AC is 15. And we want to know what is the length of BC. This is BC. Okay, so I'm going to call this X. Now, if you don't draw the picture, it's sometimes hard to see what side is across from what angle. So the picture is really important. We can see that 93 is across from 15, and 48 is across from X. So we're going to set up a proportion. Signs on top, sides on the bottom, and then angles go with the sign. So sine of 48 degrees over X equals sine of 93 over 15, because that's what's across from 93. Okay, now we cross multiply. So you're multiplying 15 times sine of 48 and then X times sine of 93.
X equal 11.2.
Okay, let's check. So if I have X times sine 93, I just want X. Since these are being multiplied, I'm going to divide to get rid of it, because division and multiplication are inverse operations. So I'm dividing by sine of 93 on both sides.
Yeah, you will.
And so I get 15 times sine of 48 degrees all over the sine of 93 degrees is equal to X. And then
11.
calculator.
11.2.
Is that the consensus?
I agree.
Yeah.
Okay. So to the nearest tenth, 11.2. Question. Okay, the you try is to find AB to the nearest tenth. See
So
if you
the
can
same, like-
figure it out. Alright, so in order for us to find this one, this one, we need this angle. So you'll find that by adding up 48 and 93. And that gives
71.
It equals 39.
41. And then we'll subtract that from 180 to get C.
39.
Okay, so this is 39. We're going to use that in our little proportions. So we have sine of 39 over y. And then what I was saying before was to use the red ones because the blue x is rounded. So sine 93 over 15 would be better.
I used the blue.
You'll probably get this, you'll either get the same answer or a really similar answer. We'll find out, right? Alright, cross multiply. So 15 times sine of 39 equals y times sine 93. And then since this is multiplication, we'll divide by the sine of 93. And let's see. Whoops,
5.5.
So I got
9.5.
9.26 or 426. So that's 9.4.
Oh, I got 9.5.
How'd you
Yeah, I
get
got 9.5.
9.5 is the
If I
answer.
just round, I got 9.46.
It was 9.45.
I got 9.426. Did I type something in wrong? Let me see. Hold on. Oh, that's not right. Hold on. I did type it in wrong. That's multiply, not divide. Yeah, okay, it's 9.45, yeah. So that's 9.5. So you got 9.5 as well.
Yeah.
If it's not perfect, it'll be really close. Alright, let's go to the next one.
Let's keep on moving.
The next one, you're finding the angle instead of the side. So you can just take a few more steps instead, but it's the same process. So to set up our proportion, you see how we have 120 and 18, they're across from each other. So we definitely want to use those two in our proportion. Sine of 120 over 18. And that's going to be equal to
Say X.
11.
something over 11. So if we're finding S, that's going to be the sine of S over 11. Don't forget the sine part, because it's the angle. So if we're finding the angle, we put sine in front of the angle. Now we cross multiply. So we have sine of 120 times 11 equals 18 times the sine of angle S. Now, we're solving for S. So if we want to get S alone, we first have to divide by 18.
So you put an 18 times sine over the same.
So you're just dividing by 18 first. So we have 11 times sine of 120 divided by 18, and that gives me
S.
the sine of S.
I move sine to the negative.
So I have sine S. Well, how do I get rid of sine? I use the
Negative.
inverse sine. So that's the sine with the -1 exponent. So inverse sine. So you're gonna sine -1. So it's gonna be the inverse sine of 11 times sine of 120 over 18 equals S, because these would cancel. Now this is gonna be a little bit trickier to plug in your calculator just because it's, you know,
Not really.
extra stuff. So if you just hit the inverse sine and then put the fraction inside of it, it should be pretty easy. Fraction bar is, or the fraction button is helpful.
Big fan.
Alright, so, since this is an angle,
I got
31 point,
32.
so I got 31.95, which we're gonna round to 31, or 32.0 degrees if you're rounding to the nearest tenth. So that's how that works. If you're rounding to the nearest tenth and you have to round up, you just say 32.0. Okay, so if you have to round all the way up, you just put the 0.0 in it.
Wait, how come this time
How come this time we had to do
just
this?
do
Because in this one we're finding the angle, and in the other one we're just finding the
okay,
side.
I was gonna ask that in the beginning. I was gonna say why, because
Yeah.
usually when we find an angle, we use the inverse sign. I didn't realize the last time we were finding a side that.
Right, so now we're finding the angle, so we use the inverse sign.
You try.
Questions?
No.
No. Is there you try? You try.
Will you draw it for us?
No.
I can, but you gotta get good at drawing it yourself. Alright, so KLM, so draw a triangle. Label it KLM.
Really good.
Really good, solid. Alright, I'll let you do the rest. A ship has been at sea longer than expected and has only enough fuel to safely sail another 42 miles. Port City Lighthouse and Covetown Lighthouse are located 40 miles apart along the coast. At sea, the captain cannot determine the distances by observation. The triangle formed by the lighthouse and the ship is shown. Can the ship sail safely to either lighthouse?
Yes.
So what we're gonna do is I need to know if this distance and or this distance
It's over 40.
is over 42.
42.
So we're finding both of those distances. So it's like we're doing two things. So 2 problems in one. So let's find x first. So I'd set up a proportion.
Sine 52 over x.
Yep. And then equals. And so we can't do 70 over y, because then we have y and x in the same equation and I can't solve for that. So I need to do,
40 over ship.
yeah, whatever this angle is. But
Oh,
we
then
can
you just
find,
add up 70 and 52
Right.
and then,
right, exactly.
let me see.
So 70 and 52 is 112,
No, well, you did faster than me.
58.
and so you get 58. So it's important to know that just because something's not given, like an angle, doesn't mean we can't find it easily, okay? But we wouldn't want to set this up using 70 and y, because then we'd have x and y in the same equation, we wouldn't be able to get the answer. So we'd have to find this angle first, and then now we cross multiply and solve. So we do 40 times the sine of 52 degrees equals x times sine of 58 degrees. We're solving for x, so all we have to do is what?
dy.
Divide by sine
Or
of
sine
58.
So you get 40 times sine 52 over sine 58
So let's
equals
see.
x.
37.2.
Oh, that's good. He can make it to that.
In conclusion, he can make it to both.
Keep accidentally touching buttons. So I got 37.2-ish, and these are miles. So can the
He's gonna
ship
make it.
can the ship sail to Port City?
Yep.
Yeah.
Yes. All right. Let's see if he can sail to Covetown, because maybe he likes Covetown better for whatever reason. So when we do that one,
Oh, I figured out. So
We know that
It's-
side now, so we can do it.
Yeah. And so it's probably better to use the red pair because they're not rounded. So I'm gonna do sine of 58 and then these two, sine of 70 over y. And we'll solve for y. So we need to cross multiply again. So I get y times sine of 58 equals 40 times the sine of 70. Now what?
dy
Divide by
sine 58.
sine 58.
I got 44.
44.3.
So therefore he cannot make Covetown.
Right.
That is not right.
Good.
Unless he wants to take the risk.
So we can say the
He has
ship
forward momentum.
can sail to, what is it, Port City safely.
Will you do it like a experiment really quick?
So
There we go. Okay, law of cosines. So the law of cosines is again used for non-right triangles when we have a certain amount of sides, angles, but not in a situation where we could use the law of sines. So if we have what we need for the law of sines, obviously that is an easier way of finding stuff. So we always want to use the law of sines if we can, but sometimes we can't. So I know that there's like 3 setups right here, just kind of focus on the first one. So in the event where we have been given the side B, the angle A, and the side C. So we have a side and then the angle in between another side, like a side angle side, like a sandwich kind of situation.
Sass.
We can't use the law of sines because we don't have like another angle, like we don't have an angle across from the side. So if we have a side angle side, we can use that to find this side. Or if we have 3 sides and no angles, we can use the law of cosines to find an angle. Okay, any angle. As long as we have 3 sides, we can use the law of cosines to find a particular angle. So I'm gonna have you write these guys down with the triangle. I know that it's like on your notes, but I want you to remember it. So I want you to write it down again, because if you write it, you'll remember it a little bit. So in example 1, do you see how we have a side and then the angle right in between,
Other side.
and then the other side? So to set it up, you're gonna take
Peanut butter.
the angle. So remember how I was having you like highlight the angle of interest? We're gonna do the same thing here. So highlight the angle of interest. Across from that angle is the side that corresponds with that angle in the law of cosines. So if you look at the second rule, do you see how it says b squared and then equals, and then all the way at the end it says cosine b? So that's how you know to set it up. At the beginning of your law of cosines, you're gonna put the side squared, and then all the way at the end you're gonna put cosine of the angle across from it. So in this case, cosine of 44 degrees. Now, in between, you square this side, you square this side. Oops, that's not a 2. Okay, and then you subtract 2 times both of these together. I ran out of room. I didn't give myself enough room. Oh no!
Rip the dream.
Okay. Alright, so again, you put whatever the side is across from the angle, either the given angle or the angle of interest. It's that side squared at the beginning, and then cosine of this angle at the end. That's why they call it the law of cosines. In between, you square, square, and then you subtract 2 times these guys. Like I said, it's gonna be really hard to remember that. So if we do a bunch of it, if we keep writing it down, you're gonna remember it a little bit better.
Yeah, it's just hard to remember the formula.
Right. Now, then we have to solve. So this is like setting up the equation, then we have to solve it. So we're solving for b, and it's squared. So if we want b to get by itself and it's squared, we have to square root it. So we're gonna square root both sides, okay? And that's gonna leave us with b equals the square root of all this stuff.
Good knees.
Now, if you're using like the TI Inspire, this can all be done in one step. If you're not using the TI Inspire, it's probably possible to do it in one step, it just might be a little bit harder.
Yeah, like I have.
You should be able to do it in one step on that calculator. You just have to use a lot of parentheses, and I have to use less. So square root 10 squared plus 22 squared minus, oops,
16.4.
let's see.
I got different answers.
That.
Like in
What?
it's
16.4.
Oh, but like doing the first one, I just leave the b square there. I didn't square root all the both sides. Like I find out the answer and then like divide.
Yeah, so if you
And it's different
round
answer.
first and then square root, then it's going to be a
I
different
got
answer.
267.
Not right.
Oh.
I
Did
got
you
like-
square root it?
The whole thing?
Did you square
Yeah,
root?
you square root the whole thing.
Yeah, then you have to square root it. Whatever you got, square root that. So do square root of the answer.
I got
72.
I got 7155511.
Not square, square root. Let me see. Oh my. Because we have 104, I'm calling that A, so it's gonna go at the end, cosine of 104. Oops. goes in here. And then a squared goes at the beginning, so it's across from the angle that we have. Then in between, you square the sides, and then you subtract double the sides times cosine 1/4. And then when you type it in, you should get, oh, so then you square root all of this.
Why don't you just put the square root over so you don't have to write it?
Sure, I just put ditto. And then you get 61.8 ish, approximately.
Ish. That's a euphemism for, you know what?
So now the next one, you're finding the angle. When we find the angle, it's more complicated because when you solve the equation, it involves more steps. So the setup is the same, but the solving part is harder. So you see how they give us all three sides? So they give us all three sides and no angles. Now, if it's a right triangle, we can use SOHCAHTOA. If we have sides and no angles, we can use SOHCAHTOA. We can use like the inverse sine or the inverse cosine or whatever. This isn't a right triangle, and that's why we need the law of cosines. Okay, so it's still like in the triangle realm, but this is for non-right triangles, and SOHCAHTOA is only for right triangles. So this just broadens our ability. So they give us all the things, and it says find angle V. So I'm like highlighting angle V. So highlight the angle of interest. Remember, the angle and the side across from it begin and end the setup. So it's going to be 4.4 squared equals, and then all the way at the end, we're going to have cosine of angle V. Okay, so beginning, end, and then in between, we square 6.7,
Wait.
7.1, and then we subtract those multiplied together. Dang it.
Oh my goodness, I'm lost right now.
So whatever is the angle of interest or the given angle, that guy and the side across from it begin and
Opposite.
end the rule.
I thought you wanted it to be V
And
squared
then-
though.
No, because that's the angle.
So,
So-
if it's a side, you do?
You do the side squared at the beginning,
Okay,
and
yeah, I
then
didn't
the
understand
cosine of the angle at the end.
that. Okay, so side beginning, angle end. Okay.
Now, to solve, V is all the way over here. So, solving this is more difficult. To solve, we're gonna start by taking, oh, I forgot my square here. We're gonna take these two and subtract them to the other side. So I'm subtracting 6.7 squared and 7.1 squared. From both sides, okay? That's gonna cancel this, and I have 4.4 squared minus 6.7 squared minus 7.1 squared equals -2 times 6.7 times 7.1 times cosine of angle V. Okay, so all I did was I just subtract the two things squared because they're being added. So I can subtract them because that's the inverse operation. Now we have all of this multiplied, right? This is 2 times 6.7 times 7.1 times cosine V. So I can just divide by all of these. And that will give me cosine V.
So you subtract
So these will all cancel.
So you just split it in half?
Sort of. Yeah, sort of.
And then you cancel out the side.
So then you divide by what's in front of the cosine.
Is -1 the inverse?
Yep.
Okay.
And now we need to get the cosine away from the V. How do we solve for an angle?
So it's like it will be inverse.
The inverse cosine, right? So the only way we can get rid of this is by using the inverse cosine of all of this.
Why'd you put that -2?
It was here, and I divided by all of that.
Oh yeah, you just moved that. Okay. So wait, for that when you separated them, that all you did was what? Just
Like
after-
here.
Yeah.
Or, so first I just took this guy and this guy, subtracted them, and so that.
So you just made a negative.
Yeah. Mhm.
Okay.
And that left me with all of this.
All right.
And then to get rid of that, I divided. So that left me with this blue stuff here. So cosine V equals all that
So you
junk.
just rewrite them over the top of one another
Mhm.
without the cosine.
And then the last step is, since I need V by itself,
Yeah.
I'm going to use the inverse cosine. Because remember when you find the angle, you use the inverse?
Yeah.
So now we're just going to inverse cosine all the stuff that we had written.
Okay, that's not
Just
that
plug
bad.
in and they say math error.
Huh? What? Say that again?
It's just like I plug all the stuff in and they show me math error.
It's probably because you're missing a parenthesis somewhere.
Ah, okay.
And so it's not letting,
yeah.
it's not letting you do that. Alright, so yeah, this is much harder to plug in.
A little bit.
But if you have my fancy calculator,
Oh my god, yeah, that's
it's a lot easier.
like $200.
I know, but it's so nice.
Oh, nice, I can't do it.
No, we're talking about AirPods. We're talking about.
Wait, did you
TI
say this is
Inspire,
like the
though.
second best calculator? You said there's one that they won't let you use.
Yeah. I got 37 point,
Why? Can you guys search on the
Zero.
internet with it?
it factors and solves things and just does too much.
It
The,
is too
the
much
other
work
one that
for
you can't use.
I
Yeah.
wanna do it.
In cash.
The first thing we have to do is figure out what this angle is right here. Okay, so this angle can be found by taking 180 and subtracting 75 because they are a linear pair. Okay, so these two angles are a linear pair, so I can subtract 75 from 180 to get this angle right here. So what's 180 minus 75?
It's
105.
So this angle is 105. Okay, now I am gonna ignore the 75 because the only reason it's there is to help you with the other one.
With
So
that angle.
we don't need this anymore. We're gonna use this, 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 and this. This angle is across from this side. So those two will start and end the setup of your law of cosines. So we have d squared, okay, at the beginning, equals, we're gonna square the other two sides, so you're always squaring sides. Sides get squared. And then minus 2 times the sides times the cosine of the angle, which is 105 degrees.
Correct, you're correct.
Now, we're finding a side, so that's much easier. All we have to do is
It's the
just
regular.
square root all that stuff.
Yep, it's pretty simple.
And then just type it in.
Pick them up.
Let's see what we get.
break it up, break it up. That song went dead so quick.
Pick it up, pick it up.
Better go high and do.
Yeah, you're right.
Okay. Oh, whoops. Type. Okay. All of that is approximately 4.5 kilometers.
Wait, I got wait.
You didn't get that.
I got